Okay, go through the possible true false. Says number one, if angles A and B are supplementary, and angles B and C are supplementary, then angles A and C are supplementary. This is actually a theorem. Um, it's called the congruent supplements theorem if you want to look it up. If you don't remember the theorem, no big deal. Because all you have to do, okay, A and B are supplementary, B and C are supplementary. So A is supplementary to B, and B is supplementary to C. And we want to know what's the relationship between A and C. You already know what it is. A and C are going to be congruent, thank you. Not supplementary. This is going to be false. Let's say that B is 50 degrees. Measure of angle B is 50 degrees. That means the measure of angle A, since they are supplementary, would be 130. Since C is also supplementary to B, that means that C would also be 130. So by the congruent supplements theorem, that would be false. It says if angles A and B are supplementary, B and C are supplementary, then A and C must also be supplementary. False. A and C, if I asked you to correct it, A and C would be congruent. Number two, if angles A and B are complementary, and angles B and C are complementary, then angles A and C are congruent. This is called the congruent complements theorem. You could prove it the exact same way. Angle A and C are congruent. What do you think? True, false? A and B are complementary. B and C are complementary. A and C are congruent. What do you think? Andrew Griffith. True. That is true. It's called the congruent complements theorem. True. Number three. If parallel lines are cut by a transversal, let's draw that. If parallel lines are cut by a transversal, then same side exterior angles are supplementary. Same side exterior. Are those supplementary? What do you think, Cody? Yes, they are. That's true. Let's go through all 5 scenarios. Same side exterior, which we just did, those are supplementary. Same side interior, which would be either these two or these two. Same side interior, also supplementary. Rewind. What's the name of those? Anybody? Alternate interior, they are congruent. These are also congruent. Those are called alternate exterior. And the last type of congruent, Teeter, we did alternate interior, alternate exterior, same side interior, same side exterior. What's the other congruent one? Corresponding. This angle and this angle. Or this angle and this angle. There's 4 sets of corresponding. Those are also congruent. So on the test, if parallel lines are cut by transversal, same side exterior angles are supplementary. True. Test at number 4. All right angles are congruent. True. Why are they all congruent? Because they all measure 90 degrees. Okay, that's your proof, right? What she just said is pretty much the proof and reasoning behind it. They all equal 90 degrees. They're all congruent. Number 5, if 2 angles are congruent and supplementary. Okay, stop there. Don't read anymore. Just think about that scenario. If they're congruent and supplementary, first off, if they're supplementary, linear pair. Then start thinking linear pair. They add up to 180. But if they're also congruent, those won't be congruent, right? This one's small and that one's big. There's only one scenario where these 2 angles would be congruent. Megan, what would that scenario be? Because this would be like 70 and 110. They're supplementary, they add up to 180, and they're the same size. They would both have to be how big? Right, straight up and down. That's the only way for them to be congruent is if they are both 90. So this says if 2 angles are congruent and supplementary, then both angles must be acute angles. False. Both angles must be 90-degree angles. Number 6. In the same plane, if 2 lines are perpendicular to the same line, then the 2 lines must be parallel. If 2 lines are perpendicular to the same line, let's draw it. 2 lines are perpendicular And perpendicular means they form right angles, right? If two lines are perpendicular to the same line, then they must be parallel. If they're perpendicular, you've actually got four, not just one, two, but actually four 90-degree angles here, 4 90-degree angles there. Question is, are these two lines parallel? This line and this line. Brandon, if the ones I marked, let's just use these. What's the relationship between this angle and this angle, Brandon? Are they alternate interior, alternate exterior, corresponding, same side interior, same side exterior? Corresponding. They're in the same place. Does everybody see that corresponding angles are congruent there if they're both 90? If corresponding angles are congruent, are the lines parallel? Yes. Did we have to use that to prove it? No, if you want to, just for kicks. Those are the same. That's also 90. Alternate interior angles are the same. This one's also 90. So alternate exterior angles are the same. They're all the same. Yeah, they're parallel. Okay. So that would be, let me read it again. If in the same plane, if two lines are perpendicular to the same line, then they must be parallel. True. Notice number 7's from last chapter, or actually first chapter. Vertical angles are always supplementary. Tirsa, are vertical angles always supplementary? No, they are always. Careful, vertical are. Here's vertical. Let me draw a picture of vertical. This angle and this angle, those are vertical. They would always be congruent. Okay. They are not always supplementary. Now, here's what throws people off. These two angles, are they always supplementary? Yes, but that's not vertical angles. Okay, that's a linear pair. These two angles are the vertical ones. These two angles are the vertical ones. Vertical is always congruent. Next one, the symmetric property of equality states that A equals B and B equals C, then A equals C. I don't think that's symmetric, correct? Taylor, that's not symmetric. What property is that actually over here? A equals B, B equals C, then A equals C. What property is that? Transitive. That's not symmetric. Symmetric property, just in case I switch this up and give you something different on tomorrow's test, the symmetric property, again, think of symmetry, not reflexive. Reflexive, you're thinking about a mirror, right? Here's your mirror, you're equal to yourself. That would be A equals A. What's on one side the same as the other side? That's reflexive. Symmetric would be if A equals B, then B equals A. Here's why we use symmetry. If you get down to the end of a proof and you have 3 equals X, and you want X equals 3, you can flip that around. That's the symmetric property. The last true false. Point B is located on line segment AC. Stop there. Point B is located on AC. Here's B. It's located on line segment AC. Next part. Between the 2 points. By the segment addition postulate, and I think this is chapter 1 as well. I go back and I put a lot of old stuff on these tests. By the segment addition postulate, we know that segment AC plus AB is BC. AC plus AB is BC. Do we know that that is true? No. No, that's just confusing. Trevor, take the segment addition postulate and actually apply it there. We know that AB plus BC, good. That's what the segment addition postulate says. This part plus this part is equal to the whole part. Okay. So that one would be false. Multiple choice. Let me explain what a negation is. I'm glad we're going over this. I've been telling you to not things. To find the inverse of something, you not the first and you not the second, which, by the way, make sure on the test tomorrow you know what a converse, an inverse, and a contrapositive is. That will not be given to you. It's not on your formula sheet. You cannot write it on your formula sheet. No converse, inverse, and contrapositive. To find the inverse, listen to what I'm saying. To find the inverse, you find the negation of the front and the negation of the back. A negation is simply the not statement. That makes sense. So what is the negation of the statement, the sun is shining? What do y'all think? The sun is not shining. Okay, let's see. A lot of people is going to make the statement, oh, well, that means it's cloudy. That's the same thing, right? Don't overthink these. Hey, please do not overthink these. Guys, if it's cloudy, or just because the sun is not shining, it could be nighttime, right? Does not necessarily mean that it's cloudy, but the sun's not shining, period. What is the inverse? Okay, to find the inverse, we not the front, we not the back. If the original statement is, if two triangles are not similar, we got not that. How in the world do you not if triangles are not similar? Oh, that's easy. You put if triangles are not similar. Correct? That is exactly right. The two triangles are not similar. What does not similar mean? They are similar. Why? Why? It's mathematical, isn't it? That's it. That's negative. And not, that's like a positive. Okay? Very mathematical. If two triangles are not similar, that means if two triangles are similar, their corresponding angles are not congruent, which would be they are congruent. So the inverse of this would be if two triangles are similar, their corresponding angles are congruent, which would be, I believe, A. If two triangles are similar, their corresponding angles are congruent, which is A. Move along. Number 13. We're asked to find the converse of the statement, if Bob does his homework, then George gets candy. I believe this was one of our warm-ups one day. Converse. Remind me, Austin, Reed, how do we find the converse of a statement? You're going to flip the front with the back. So instead of if Bob does his homework, it's now if George gets candy, then Bob does his homework. If George gets candy, then Bob does his homework, D. Number 14. What is the contrapositive of the statement? If I am tall, then I will bump my head. In order to find contrapositive, you not and you flip. You find the negation of each and you flip them around. So if you want to find the negation first, is not tall implies not bumped. And then flip them around, not bump implies not tall. So if I do not bump my head, then I am tall. No, that's not right. If I do not bump my head, then I am not tall. B, final answer. Next problem says, based on the diagram, which statement is true? Based on this drawing, what is true? We're looking for which lines are parallel. Guys, you cannot go by if they look parallel. I already told you that once. This is 110. This is 60 here, so that makes this 120. Would these be parallel? No. Because in order to be parallel, corresponding angles have to be congruent, or alternate interior, alternate exterior have to be congruent, or same side interior, same side exterior have to be supplementary. So look, 110, 120, and 115. None of these are congruent because those corresponding angles, none of them line up. So let's check these two. This is 60, this is 120. Supplementary, linear pair, that makes this 60. That makes those two lines parallel because corresponding angles there are congruent. Therefore, E and D would be your two parallel lines. So, what can we conclude? A, that D is parallel to E. Next problem. It says, in the diagram below, line N and M are cut by transversals P and Q. What would make the lines parallel? Okay, and in order to be parallel, you just do it backwards. Okay, if you could somehow force the corresponding to be congruent, alternate interior, exterior to be congruent, or same side interior, exterior to be congruent, these lines would be parallel. So let's see what values that we would have to have for these other angles in order to be parallel. In order to be parallel, alternate interior would have to be the same. So 30. Is these two not already equal regardless? You see the vertical angles there? I'm writing down everything I know. 80 and 30s, everybody see the straight line. I believe the straight line, those would have to add up to 180. So I have an extra 70 would make it 180. And that would be enough information. What does x have to be? 70. Because in order to be parallel, alternate interior angles have to be the same. If this is 70 up here, these are alternate interior. Here's a good way to check for alternate interior. You want these two lines to be parallel, correct? You'll have a Z shape. Anytime you have alternate interior, you've got that Z shape. So alternate interior must be the same. Each of them have to be 70. Next problem says that line N intersects lines L and M, that's the transversal, forming the angles shown in the diagram. What value of x would prove that L is parallel to M? These two angles here, McKenna, what's the relationship as far as names? What's the named relationship we give to these two angles? Alternate interior. In order to be parallel, those would have to be congruent or equal in measure. So therefore, we're going to set them equal to each other. 6x plus 42. 6x plus 42 would have to equal 18x minus 12. Let's solve that in our head. Garrett, how are we going to move 6x to the right side? Good. So I now have, instead of 18, I now have 12 x's. Garrett, how would I move minus 12 to the left side? Add it, and you would have 54. Last step, let's divide that by 12. It does not divide evenly. So you can use your calculator to divide it, or just reduce it. Anytime you've got a division problem, this is your extra algebra content of the day. Anytime you have a division problem, treat it like a fraction, because it is a fraction. Division and fractions are the same thing. Reduce this fraction by dividing by 6, maybe, and you get 9 over 2. If you want to divide 9 by 2, you're going to get 4.5. It's just much easier. If you can reduce that in your head, 54 divided by 12 is 4.5. Or you can reduce it, 9 divided by 2 would give you the exact same answer. So 4.5, which value of x would be B? A transversal intersects two lines. Which condition would always make two lines parallel? So this is just testing you on the same thing. I would know all about parallel lines, obviously. If vertical angles are congruent, does that make the lines parallel? No. If that were true, guys, let's think. That would make every line in the entire world parallel. Because vertical angles are always congruent, regardless. So just because two vertical angles are congruent does not mean that lines would be parallel. If same side interior angles are complementary, does it make two lines parallel? Change that word complementary. That should be supplementary. Then that would be correct. Same side interior angles must be supplementary, so no, that's not true. Would corresponding angles have to be supplementary? Corresponding angles would have to be congruent. Alternate interior angles would have to be congruent. True. That would be D there. Next problem says the dashed line in the figure below represents a proposed bike path that crosses the two parallel streets. The measure of angle 1, which is here, is 32 degrees. What's the measure of angle 2? I didn't have to copy that, did I? If angle 1 is 32 degrees, by name, Pacey, what is the relationship between 1 and 2? Those are alternate exterior angles. Alternate exterior angles are always the same. So if that's 32, then this is 32. Done. That'd be B answer. First proof that's going to be on the test. And I'm not going to make you prove a whole proof of anything. This proof says AC is perpendicular to GE. AC and GE are perpendicular, so you have right angles there and there. GD and BF are also perpendicular. GH bisects, this dotted line bisects this EGD. And the measure of BGC is 36 degrees. Well, I say it's proof. It's not a proof, is it? That's just given. It says, what is the measure of angle EGH? Okay, so here we go. AC is perpendicular to GE. That makes this a right angle. Let's do it in red so we can see it better. This would be a right angle, and this would be a right angle. I'm going to go ahead and put BGC. Let me find BGC. BGC is 36 degrees. We're also given that GD, which is this, would be perpendicular to BF. So that makes this a right angle, and it makes this a right angle. GD and BF. Okay. Guys, if this is 36, it just told us that this BGD is a 90-degree angle because it's perpendicular. If this is 36, then that makes this 54. Everybody follow me? GH bisects EGD. Not only do you have a right angle here, but this EGC, everybody see that, is also a right angle. So do you see that this part, and this is a pretty tough problem, you see that this here, if this is 54 here, how big will this whole angle be? Also 36. But you've got a bisector here. And to bisect means to cut perfectly in half. So what I'm going to do, since the whole thing is 36, I'm going to distribute that and put 18 and 18 there and there. And I don't know what they're asking for. I'm just giving them everything. If that's 36, you also have a right angle here. That makes this angle also 54. And that would make, since you have a right angle here as well, that would make this angle 36. So now let's see what they're actually asking for. EGH. EGH would be 18 degrees. On this next problem, you might be asking, what in the world does this have to do with geometry? If you don't remember, we started off the chapter talking about inductive reasoning. Inductive reasoning is a reasoning based on patterns. So if this pattern continues, notice it says if the pattern continues because inductive reasoning can be wrong. It's saying if it does continue, what would be the next figure in the pattern? Just pointing out that the first figure has 4 dots, the second figure has 3 dots, the third figure has 2 dots, the next figure will have 1 dot, which helps you none at all. They all have 1 dot. The first figure has no lines, 1 line, 2 lines. I would say the next one would have 3 lines. That one has only 2. This one has 3, and this one has 3. So now we're down to A or D. The first triangle is pointing up, down, so that gives you an answer of D. Okay, just look at your patterns. That's called inductive reasoning. Now here's your first proof. What statement completes the proof below? We are given that angle 1 is congruent to angle 2, and unfortunately for you, I gave you that step. Angle 1 is congruent to angle 2, given. We're also given, that's it. No. We're given that angle 1 is congruent to angle 2. We have to somehow prove that angle 1 is congruent to angle 4. So the intermediate step, which I do give you that the intermediate step is proven true because vertical angles are congruent. That narrows down the answers. Since vertical angles are congruent, what would be our actual statement there? Well, it would have to be either 1 and 3 are congruent or 2 and 4 is congruent. But which one would actually help me with this proof? So here we go. Let's try it like this. We're given that angle 1 is congruent to angle 2. And from there we go to some intermediate step. And from there we go to our final answer, which is angle 1 is congruent to angle 4. And we do know that to get from here to here we use the transitive property. And for those of you that know the transitive property, that alone can tell you what your answer is. Transitive property says if one thing is congruent to another thing, and that other thing is congruent to a third thing, then the first and third thing must be congruent. Just from that, and not even looking at the drawing, what has to be the missing blank? Angle 2 is congruent to angle 4. Because if 1 is congruent to 2, and now if 2 were congruent to 4, then we would know that 1 is definitely congruent to 4 by the transitive property. Now let's make sure that fits though. 2 and 4, are they? Yeah, those are vertical angles, so that would fit there. Angle 2 is congruent to angle 4. So as in the following proof, what is the reason for step 4? We're given that transversal K intersects M and N, and we're given that the measure of angle A is congruent to measure of angle B. We want to prove the lines are parallel. They said, okay, here's my given. They also said that A and C were the same because vertical angles are congruent. Then they said that C and B are the same by the transitive property. Well, how in the world did they go there? Look what was given. You were given that A and B were the same. We then said that A and C were the same because they were vertical. So now we know that C and B are the same by the transitive property. So since we know that C and B, look where you're going from. You're going from C and B being the same to now the lines are parallel. Look at C and B. C and B, Hannah, are what type angles? So we're using the fact that corresponding angles are congruent to prove that the lines are parallel. So what's my missing reasoning? Look at this. Okay, here's what not to do. Let me find the not right answer. D. Look at D. If two parallel lines are intersected by a transversal, then corresponding angles are congruent. That's not what we're using. We're trying to prove that the lines are parallel. We're not trying to say they're parallel, so therefore corresponding angles are congruent. We're saying since the corresponding angles are congruent, that implies that the lines are parallel. We're actually using the converse of one of those original theorems, which I believe would actually be C. Is that right? If two lines are intersected by a transversal and corresponding angles are congruent. If corresponding angles are congruent, then the lines are parallel. That's the justification. We're proving that they're parallel because corresponding angles are congruent. Number 24, talk about, there's only two laws we did. Let me remind you of that. As far as when we discussed deductive reasoning, we did law of detachment and we did law of syllogism. The law of detachment said if you know that A implies B and that A is true, since A implies B, then you also know that B is true. That's the law of detachment. The law of syllogism is pretty much the transitive property. The law of syllogism says if A implies B and B implies C, then A happening must imply that C is happening. That's the law of syllogism. Number 24, if it rains, then I'm bringing an umbrella to school. As I look outside, I see that it is raining. Thus, I carry an umbrella to school. This is an example of which one of those laws, Madeline? Is it the law of detachment or is that the law of syllogism? It says if it rains, then I am bringing an umbrella. Okay, what if I look outside? It is raining. So I'm bringing an umbrella, right? That's the law of... Okay, let me go over the two laws. Detachment. It is detachment. Let me go over them one more time. The law of detachment says this. If something happening implies something else happening. We know that if it rains, then I'm bringing an umbrella. If A implies B is true, and we know that A is true, which in this statement, A being true means it is raining. We know that if it is raining, then I'm bringing an umbrella. We look outside and we see that it is raining. Therefore, we know that what's true? Bring an umbrella. That's the law of detachment. A implies B is true. If we know A is true, then we also know that B will be true. This next problem. 25. If you give me $1, then I will buy a Coke. If I buy a Coke, then I am sure to drink it. Thus, if you give me $1, then I am sure to drink a Coke. This is an example of which law in? Is that detachment or syllogism? Syllogism. Don't put Newton's law. Okay, that's not this class. Next problem tests you on your different laws or properties of equalities. It says if x plus 3 equals 5, then x equals 2. We know this is true because of, Trey, what do I do to get rid of that plus 3? What am I going to do to move that plus 3 over? Solve this equation for me. X plus 3 equals 5. To get rid of plus 3, I'm going to come over here and move it and do the opposite, which is the opposite plus, which is the minus. Okay. You're subtracting 3. That would be the subtraction property of equality. So by the subtraction C, the subtraction property of equality, we know that X must be 2. Number 27, line A is parallel to line B, and line C is perpendicular to line A. Let's draw it. Anytime you have a situation, I can't read that and make any sense of it. I have to draw it or I'm not going to get it. Line A is parallel to B. Let's draw line A and B. Here's line A, here's line B. They're parallel. Which, by the way, they're parallel because they have the same slope. I know those don't look parallel, but we're going to assume. Line A is parallel to line B. We're also given that line C is perpendicular to A. So let's draw that to be perpendicular. Line C is perpendicular to line A. What can we conclude? Cat, since this is a 90-degree angle, that's what perpendicular means. You got 4 90-degree angles. Corresponding angles, Cat. If this is 90 degrees, how big is this angle right here going to be? Because it's corresponding, correct? So does everybody understand if it's going to be perpendicular to A, it's going to be perpendicular to B as well? So that's what we can conclude. Line C is also perpendicular to line B, C. Next problem. Okay, here we go. What is the length of line segment QR? Reminder, this is a perpendicular, there's why it's perpendicular, it's got the box there, bisector. It cuts it in half. Line SR is a perpendicular bisector of QT. Any point on that perpendicular bisector will be the same distance from the endpoints. So here the equation we're going to set up, 2x plus 3 would have to equal 4x minus 7. Let's solve it in our head. Dylan Davis, move the 2 x's to the right side. How many x's do I now have? Good. Move the minus 7 you now have. So x must be good. Which is an answer choice, notice. 5, that's wrong. Make sure you plug it in because it's not asking for x. It says what is the length of segment QR. QR is 2 times 5 plus 3, which is 13. Go ahead and plug it in here to check it. 20 minus 7, also 13. So length of QR would be 13 units. I will explain 29. We're not doing yet. If we have time at the end, I'm going to go back and do what's called constructions. You can actually, with a compass, you can find a perpendicular bisector really easy. See if you can follow this. If you have a line segment, you could take your compass and open it to any, and a compass, one of those things that draw circles, okay? Take your compass and just open it to anything wider than halfway and keep it set there. Keep it to that distance and measure or draw an arc. Okay, you don't have to draw the whole circle, but just draw an arc right here. With the same opening, come over to this other side and draw the exact same arc. Connect the dots. Look what you got. Perpendicular bisectors. Here's why. We just learned that any point on the perpendicular bisector is the same distance from A as it is from B. Do you see how that fits? When you open, let's say that you open your compass to 6 inches, and you strike this 6-inch arc, this 6-inch half circle, and this would also be a 6-inch half circle. Well, if it's 6 inches from here, and it's also 6 inches from here, if a point is the same distance from here as it is to here, it has to be on the perpendicular bisector. Same point down here. This is 6 inches away, and this is also 6 inches away, so it must be. Those 2 points have to be on the perpendicular bisector. The answer there would be C, but that one won't be on your test. Number 30, also not on your test. It's also another construction. It's about constructing a line parallel to a given line, so we can skip number 30. On to 31. If two angles form a linear pair, hey, this is review. If two angles form a linear pair, Thakerson, then they must be supplementary, B. They're not congruent, they're not vertical, they're not complementary. Vertical angles are actually congruent, so that's they're supplementary. Number 32, line M is parallel to line N. Therefore, Colby, the two angles that are given, which are what type of angles? They are both right angles, and the relationship between the two are corresponding. These two corresponding angles have to be congruent. So like you said, they're both right angles. So your equation there, 5x minus 20 would have to equal 90. And if you set that up and solve it, 5x minus 20 would have to equal 90 in order for that to be true. Move the 20 over. 5x would have to be 110. Divide by 5, you get x is 22. But always make sure what I'm asking you. Find the value of x. Okay, we're safe. C, 22. And number 33, which I believe is the last problem, sure enough. Number 33 says the two lines in the figure below are parallel. What is not true? That's actually the exact same shape. Remember that proof we did the other day that I had a little trouble with? It's the same one. Now I'm giving you, we're working a little bit different now. It says they are parallel. Let's assume that we have parallel lines. The two lines in the figure below are parallel. What is not true? Okay, let's just take them one at a time. Harley, angle 4 and angle 5 are congruent. Is that going to be a true statement? Yes, it is. Because angle 4 and angle 5 are vertical. Does everybody understand? They are congruent. Sabrina, B, angle 3 and angle 5 are congruent. Let's skip that one. Angle 5 and angle 6 are congruent. Would that be true, Sabrina? Yes, because they are. Here's alternate interior. Here's my parallel lines. Here's my transversal. They're on the opposite sides of the transversal, and they're also inside, alternate sides of the transversal, inside the parallel lines. 5 and 6 are alternate interior. Those would be congruent. 3 and 6 are complementary. Roderick, would 3 and 6 be complementary? Yes, because these lines are perpendicular. Y'all see the right angle here? That means you have a right angle here as well. So 3 and 6 would be complementary. So obviously, the correct answer would be B. They're not congruent, but they do have a relationship. Let's go into this. This is extra information. Since this line is perpendicular and these are congruent, or excuse me, these are parallel, that makes this a 90-degree angle as well. You don't know this yet, or most of you do, but the three angles of a triangle add up to 180. So do you know what the relationship between 3 and 5 would be? They add up to, this is 90 already, right? So the other two would have to add up to, would they be 45 apiece? It doesn't say that they're congruent, right? Because if that was true, this would actually be true. But they're not necessarily 45 apiece, but they do add up to 90. Angle 3 and angle 5 would be complementary because this is a right angle. The 3 add up to 180, so therefore 3 and 5 would actually be what's called complementary.